Physics. The word came from Greek word physikos, which means knowledge of nature. People who learn and discuss physics are called physicists. The aim of this group of people is to provide precise and correct description of events happening around us in nature as simply as possible based on various scientific notions. In a statement, physicists say physics is the subject of studying and interpreting nature and natural phenomena. What is the dimension of physics? As already mentioned, it is knowledge of nature, and over time we found physics includes domains ranging from subatomic to galaxies. To quantify and have some idea, let us represent them in terms of known parameters, which we are very much familiar with. Subatomic domains can be of the order of 10 to the power minus 14 meter, where the interactions can take place in 10 to the power minus 22 seconds and can have mass in the range of 10 to the power minus 30 kilograms. So, how small is 10 to the power minus 14 meter? If we divide 1 meter into equal 100 portions, we get a centimeter or 10 to the power minus 2 meters. Yes, that much reduction in size brings it down by just 2 orders in magnitude. We have to go down by another 12 orders to reach 10 to the power minus 14 meter. Imagine how small 10 to the power minus 14 meter can be. Similarly, we can think about 10 to the power minus 22 seconds or 10 to the power minus 30 kilograms. On the opposite side, galaxy size can be of the order of 10 to the power 25 meters, where the event durations can be of the order 10 to the power 18 seconds with mass ranging from 10 to the power 55 kilograms. This is how vast the domain of nature and natural phenomenon. This is how vast the topics of physics can be. Even though physics is a vast subject and has earned the reputation of a difficult one, but it is still considered as a simple and basic subject. That is because physicists wanted to describe the natural observation at most basic level with simple scientific notions. We'll come back to scientific notions in a moment. First, let us discuss about the interactions and force observed in nature. All the observed interactions can be included in four fundamental types of interactions named gravitational, weak, electromagnetic, and strong. In terms of relative strength, they are in the ratio 1 is to 10 to the power 26 is to 10 to the power 36 is to 10 to the power 39. Let us move on to gravitational interactions. Gravitational interactions exist due to mass of a body. It is an attractive interaction. Any two objects having some mass and are separated by some distance exert gravitational force on each other. It is a central force, which means that it acts along the line joining the two bodies. Gravitational force is a long-range force and follows inverse square law. It means the strength of the force is reduced by 4 times if the distance between the object becomes twice. On the other hand, its strength increases by 4 times if the distance of separation becomes half. Field particle of gravitational interactions is termed as gravitron. Next, we have weak interactions. Through weak interactions, light elementary particles interact among themselves and with heavier particles. An illustration of beta decay is shown which contain weak interactions. Field particle of interaction is termed as neutrino. Now we move to electromagnetic interactions. Our daily activities are mostly influenced with electromagnetic interactions. Like gravitational interaction, electromagnetic interaction is also a central force and follow inverse square rule. However, electromagnetic interaction can be attractive as well as repulsive in nature, unlike gravitational interactions, which can only be attractive. Similar charges and like poles repel each other, whereas opposite charges and opposite poles attract each other. The field particles for electromagnetic interaction is photon. Finally, we move to strong interactions. Strong interactions are of nuclear origin. They are extremely short ranged, yet most powerful in nature. Strong force is non-central and do not follow inverse square rule. An illustration showing how strong interactions put proton and neutron together inside a nucleus, field particle of nuclear forces, is called pi meson. Now let us discuss about scientific notions. At first, law. A law is a concise statement of happenings in nature after repeated observations and experiments. For example, let us consider the law of gravitation partially, which states that two objects attract each other. A law is based on observations and experiments. Hence, in case of law, no ifs and buts can be raised. No question can be raised why two bodies attract each other because it's a law based on huge number of experimental observations. Next scientific notion is theory, a conceptual basis supported with mathematical arguments to determine specific laws is known as theory. Theories are created to explain the observations and should not be derived from the observation itself. Next, we have model. Model is the visual picture of a phenomenon under investigation. The purpose of a model is to help visualizing any phenomenon. As an example, let us consider light as a wave. We cannot see wave of light, but we can see water waves. Keeping the water wave visualization in mind, we can interpret various properties of light. Finally, method. Logical reasoning and controlled reproducible experiments are the basis of scientific method. Experiments should be reproducible, that means they should lead to the same outcome under same circumstances and must be independent of observation time or observer. These are the main four scientific notions. Now let us look at the timeline of some of the important inventions and discoveries related to physics. It should be noted that before 1890, physicists were mainly focusing on macroscopic nature. Most of the phenomenon can be well explained with the knowledge acquired from macroscopic physics. Today, physicists call this as the era of classical physics. However, close to 1890, various observations were found which has no explanation based on classical physics. These observations can only be explained with the knowledge we acquired from quantum realm. The year 1890 is often marked as the beginning of modern physics. Based on the timeline, we can clearly conclude in today's society, physics influence and get influenced with other subjects too. Most of all, mathematics. We can say mathematics is used as the language of physics. Material development interlinks physics and chemistry. Biology, medical science, and many other subjects like communication, meteorology, computer science, electronics are heavily studied in physics. With developing knowledge, it has become essential to divide physics into various branches and specialization. Classical mechanics, optics, electrodynamics, heat and thermodynamics, quantum mechanics, solid state physics are just some of the branches of physics. Now let's discuss the important concept of a system. By definition, a system is some part of the universe in which we have interest. Rest of the universe outside the system is termed as surrounding. As an example, let us consider a pan of boiling water. If we are interested to study the properties of the pan filled with boiling water, we can consider it as a system and rest everything becomes surrounding. In this particular case, we can study how much amount of water is there, how the temperature of water is falling with respect to time, etc. Systems can be isolated or interactive. In isolated systems, some important physical quantities always remain conserved, like energy, momentum, and charge. This is also referred as conservation law. Conservation law reflects one of the most basic way of describing nature. Finally, let us conclude the introduction with one of the smallest and very significant expressions in physics, E equal to mc square. We can relate this expression from subatomic domain to galaxies. In other words, to our very existence.